In this video, we're going to talk about exponent rules. First, I want to review what an exponent is and what it means. If you have something like 2 to the third power, that means that you're going to take 2 and multiply it times itself 3 times. So 2 times 2 times 2, and 2 times 2 times 2 is 8. So we can read that as 2 to the third power, or the third power also has a special name. We can also read that as 2 cubed. Either way, it means 2 times 2 times 2, which is 8. This is 7 to the second power, or 7 squared, and that means 7 times 7, which would be 49. So a power of 3 and a power of 2 each have a special name. The power of 3 is cubed and the power of 2 is squared. Other than that, we just say 3 to the fourth power, like right here. Or if we have a fifth power or sixth power, they don't have a special name. So 3 to the fourth power means 3 times 3 times 3 times 3. Now you can multiply that in order. Do 3 times 3 is 9. 9 times 3 is 27, and then 27 times 3, or if you want to break it up, you can do 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. So 3 to the fourth power would be 81. Then I want to show you a special case where we have to be careful when we have a negative number raised to a power. If the negative number is in parentheses, then that whole thing is being raised to this power. Negative 5 squared, or negative 5 to the second power, means negative 5 times negative 5, and that would come out to be positive 25. However, if you have something like this is not the same as this, okay? We have to follow order of operations, and this negative, I want you to think of it like it's not attached to the 5 because it doesn't have the parentheses attaching it. So the negative is actually not being raised to the second power, only the 5 is. So you can think of it like this. We're going to do 5 to the second power, and then we're going to put the negative on there, and so it's going to end up negative 25. If it helps you, you can also think of it like when you see that negative out front, you can treat it like a negative 1 and kind of pull it all the way out to the front, and then you have negative 1 times 5 squared, negative 1 times 25, which is negative 25. But either way, when you do these, they're different. And if you use a calculator, you have to be careful, because when you square a negative number or raise a negative number to a power, you need to put it in parentheses and raise it to that power. Otherwise, your calculator will treat it like this, and that might not be what you mean. All right, so now let's get into rules for exponents. When we are multiplying terms that have the same base, then the rule is that we are going to add our exponents. Now the base stays the same. It's the exponents that we add. All right, so let's see. If we have w squared times w to the fourth. All right, the bases are w, okay, and so that base stays the same, and we add 2 plus 4 is 6. Now, if you think about it, that should make sense. W squared is w times w. W to the fourth is w times w times w times w. And how many w's does that make? W to the sixth. That's why we add. Okay, now that works even if it's a number base. You have 2 to the third power times 2 squared. All right, the base can stay the same, and we add the exponents, and then this one we can actually work out. 2 to the fifth power means 2 times 2 times 2 times 2 times 2, and that would be 32. All right, so that's the rule for multiplying terms with the same base. The rule for dividing terms with the same base is that we are going to subtract exponents. Again, the base will stay the same. We will just subtract the exponents. All right, so let's show an example. If you have m to the 6th divided by m to the 4th, bases are the same. The bases are both m, so the base stays the same. 6 minus 4 is 2. Okay, let me show you why that works. If you have m to the 6th on the top, that is this, m times m times m times m times m times m. You don't want to have to write that out every time. That's why we have these nice little rules. And on the bottom we have m to the 4th. And if you'll notice, we can cancel some like terms on the top and the bottom. And what are we left with? We're left with m times m on the top, which is m squared. But again, we don't want to have to write this out every time. And so we've realized that when you're dividing, the quick way to get the answer is to subtract. If you have 6 m's on the top and 4 of them are going to cancel, 6 minus 4 is 2. All right, same up here. You can do it with a variable. You can do the same rule if you have a number base. 3 to the 5th power divided by 3 squared would be 3 to the 3rd power. 5 minus 2 is 3. All right, and 3 to the 3rd power is 27. Okay, same thing. If you wrote it out, 3 times 3 times 3 times 3 times 3 over 3 times 3. You see that 2 pairs are going to cancel. You're going to have 3 3's left on top, so 3 to the 3rd power, which is 27. All right, so let's put some of those rules together. What if we have a to the 3rd times a to the 8th divided by a to the 7th, okay? In order to use the rules, remember the bases have to be the same, so all of our bases are the same here. On the top, we're multiplying, so we're going to add our exponents. So we'll have a to the 11th divided by a to the 7th. Now it's division, so we're going to subtract our exponents, and we end up with a to the 4th. Okay, we can do the same thing with a number base. 5 to the, that's a 9, 5 to the 9th power divided by 5 squared times 5 to the 5th. You want to combine the denominator first. This is multiplication, so you would add your exponents and get 5 to the 7th. And then you would, this is division, so you'd subtract your exponents and get 5 squared. And 5 squared is 25. Okay, so now we're just going to take those rules and put them into practice with some problems that have both rules in them. Let's see. What if we have negative 3 p squared q to the 4th times 2p q to the 5th? Okay, so this is multiplication. The parentheses indicate that we're multiplying. Now, when we have coefficients in the front, which are the numbers in the front, we are going to just multiply those because this is a multiplication problem. Negative 3 times 2 is negative 6. Now, for things with exponents, we're going to use our exponent rules. This is, again, multiplication, so we're going to be adding our exponents. For the p's, we have p squared, and then this p has an understood exponent of 1. So when we add those, we're going to get p to the 3rd, and then q to the 9th, because 4 plus 5 is 9. Okay, let's do one more like that. Negative 4a cubed bc times negative 6 a b squared c. All right, once again, we're going to multiply the coefficients that are in the front. Negative 4 times negative 6 is positive 24. We're going to add our exponents for each different variable. So we'll have a cubed times a. That's an understood 1. So for the a's, 3 plus 1 is 4. For the b's, this has got an understood 1. 1 plus 2 is 3. For the c's, 1 plus 1 is 2. Okay, so 24, a to the 4th, b cubed, c squared. All right, 16, w to the 9th, z to the 3rd, divided by 4, w to the 8th, z. All right, so this is a division problem. When we have something written as a fraction, it's really just division. And so we are going to do 16 divided by 4. 16 divided by 4 is 4. For our terms that have exponents, we'll use our exponent rules. For division, we subtract our exponents. So for the w's, 9 minus 8 is 1. You can put the 1 or you do not have to. It's understood to be there. And then for the z's, 3 minus 1 is 2. All right, let's see. Let's try one more division. All right. Again, the numbers in front, we divide because it is a division problem. 14 divided by 7 is 2. We'll subtract our exponents here. For the c's, 4 minus 3 is 1. And for the d's, 5 minus 1 is 4. Okay. We treat it the same, even if we have more than 2 things being multiplied together. We still follow the rule. Okay, here we've got 3 things being multiplied together. We can multiply all the coefficients together. Negative 2 times 3 is negative 6. Negative 6 times 5 is negative 30. Then we have v's, so we have v squared, v to the 1st, and v to the 5th. We're going to add those exponents and get v to the 8th. All right, last one. M to the 3rd times m to the 11th over m to the 4th times m to the 6th. Now, as long as you follow your rules, there are several ways to do this. Probably the way I would do it first is do the top as a multiplication problem, the bottom as a multiplication problem, and then handle the division. So on top, we're going to add our exponents, get m to the 14th. On the bottom, we're going to add our exponents and get m to the 10th. And now it's a division problem, so we're going to subtract our exponents and get m to the 4th. All right, that wraps up this video. I'm going to do the next video on how to handle a power raised to a power, which is another exponent rule. So if you need that one, you probably want to go ahead and watch the next video as well.